Here's integrated 3. It's 8-118. It's a really long problem, so I did some of the calculations ahead of time. But it says the Algiers High School Booster Club is planning a fundraiser to collect money for a new synthetic turf field and stadium lights. The boosters will completely cover the football field with playing cards 2.5 by 3.5 inches face down. All the cards are aligned in the same direction as the football field, long side of the card along the long side of the field. There will be exactly one joker card placed at random among the cards on the field. The football field is 100 yards by 53 1/3 yards. Contestants pay $5 for every card they wish to turn over and then replace the card. Whoever finds the joker wins $1 million. What's the probability of randomly finding the joker and turning over one card? Well, I mean, the answer key it gives you all the numbers, but I thought I would explain that a little bit. So the probability is going to be, well, first of all, to find probability is favorable over total, right? So it's going to be 1 over however many cards there are. So we need to figure out how many cards there are, which is a little bit of a task. So it's a football field. So if we could figure out how many cards will fit across and how many cards will fit down, then we can multiply those two numbers together and we can find out how many cards there are, and we know that the probability is just going to be 1 over however many cards there are. So the cards are given in inches, so we can convert the field measurements to inches. So there's 3 feet in a yard, so I multiplied each of these by 3 to find out how many feet they are, and there's our feet. And then I know that there's 12 inches in a foot, so I multiplied by 12, and I got the dimensions of the football field in inches. And then you can divide, like this is the short side, so I'm going to divide this by 2.5, and I'll divide this by 3.5, and that'll tell me how many cards will fit across. So I just showed that I divided. And so I can fit 768 cards across the short side. And this is weird throughout this whole problem. I can fit 1,028.57 cards across the long side, but I noticed that I guess we're going to let it overlap a little bit, and your book rounds that number to 1029. So the numbers are going to be all a little bit funky because depending on how, like if you left the rounded big long number in your calculator or not. I decided to take my number and just round it to wherever the answer key rounded it. So we're rounding up. So they're choosing to let it overhang a little bit. Okay, so then if I multiply these two together, then I'll know how many cards altogether. And so now this is my number of cards that I have. And then so probability is favorable over total, so it's going to be 1 over however many cards. So there's only one joker in all these 790,272 cards. So then I just wrote, 1 over the number of cards, and then I got, my calculator gave me this, it's in scientific notation, so I just moved the decimal over, and I get this little, pretty small probability, but hey, you're going to win $1 million if you flip over that card that has the joker. Okay, so then letter B. Letter B says the playing cards used to cover the field cost 99 cents per pack. And there's 52 cards in each pack. So I went ahead and grabbed the number. Remember, this is that number that we got of how many cards there are, and divided it by 52 cards. And I got another decimal number. And then I rounded. Well, the book rounded too. So now we keep rounding, and things are going to get a little off every time we round. So I've got that many packs. 99 times 99 cents per pack, and I got, this is about the amount of money that all the cards will cost. So that's actually a lot of money just to buy all the cards. And then it says, what's the largest amount, on letter B, it says, what's the largest amount of money the boosters can lose in this fundraiser? So they already paid out $15,000-ish for all the cards, and then they can also lose, you know, if somebody, basically the boosters will lose money if the very first person who pays their $5 picks up the card that actually is the winning card. There's only one out of 790,000 some odd cards. But if that did happen, then the boosters, well, they have to pay $1 million because the person won, and they also have already paid $15,000-ish for the cards. So that puts them, you know, they got $1,015,045.56 in debt, but they can subtract $5 off of it, because whoever it was who turned over that first card and got the Joker, they paid $5 to turn over the card. So really the most that the boosters can lose is a lot, $1,015,040.56. I think your book has that rounded to $1,015,041.02 or something. But I'm gonna stop rounding the way they do, and I'm just gonna let mine round the way it rounds. But it's still very close. And then letter C says, what's the maximum amount of money the boosters can make? Well, they would make the most money if every single card got turned over and the very last card was actually the Joker. Like, so in other words, if they got $5, because every time someone turns over a card, they get $5. The boosters get $5. So I found out that's how many cards there are, and then that's how many $5 bills they would get if every single card got turned over, which gave me this big giant number. And then I thought, well, now we have to subtract all the money they've paid out. The boosters, well, they have to pay out $1 million to the winner, and then they have to also subtract out the cost of the cards. And if you remember, we did all this hard work and got the cost of the cards. And so this is approximately how much the boosters, the most they can make, like almost $3 million. It's a lot of money. And then letter D says, what is a reasonable expected profit for the booster club? That is, if the fundraiser were done many, many times, what would the average profit? So you could just average these two case scenarios, like it's probably not going to be the first card that gets picked or the last card that gets picked. So you can just make this assumption that probably about halfway through the cards, you know, or in other words, you sell half of the you get your $5 for half of the cards before the Joker gets overturned. So that's the number of cards you have. So for half of them to get turned over before the Joker turns up, I just divided by 2, and then that's how many cards actually got turned over before the Joker was revealed. You get paid $5 for each of those cards, so I multiplied. Got this big number. And then we still have to subtract out however much money we paid for the cards, like when we went to the store and we bought all the decks of cards. So subtract that off. And then subtract the $1 million that you pay out, and then you get $960,634.44. I think your answer book has it $960,633.98, but it's, you know, very close. And then letter E says, a state Mucho Millions lottery advertises odds of 176 million to 1. If the state lottery were played like the Booster Club fundraiser, how many football fields covered with non-joker playing cards would be needed? So remember, the way that they were playing it with the Booster Club was 1 out of 790,272. There's only one joker in that many cards. Oh, you can't see it. So multiply that by 176 million, and you get 223 football fields would have to be covered to give the same odds as winning the state lottery. Yep. And that's it.